I am again considering a particle. I am drawing a different curve but of the similar type just to entertain you, because if I would have used the previous curve in all the pages, then you may get bored. So just because of you, it is my faith on you. It is your faith on me on which we are sitting here together. So just mean it. I am drawing again the same curve for the particle which was moving from time t1 to t5 and position from x1 to x5. What we are doing here, we are getting information about the changing velocity of the particle. As you know, velocity is changing continuously as at different points we got tangent with different angles. At some places it is positive, at some places it is negative angle. So particle at some times moves in forward direction, while on the same position when it reaches in its backward motion it has negative velocity. So a different tangent has to be drawn to explain that. Now if we talk about how I will get the complete information about changing velocity of the particle using the same position time curve. See, as an example, I am again drawing the position time curve for the particle. On this axis we are taking position of the particle, taking in this direction to be forward. Here on this axis we are taking time. We will not talk about the positive and negative time because time never returns back. It always moves in forward direction. So say that various time which we have indicated in the previous curve were t1, t2, t3, t4 and t5. Obviously these times may get changed because I am not the perfect man to draw any curve. See, just take its mathematical and graphical utility. Don't go on the measurements of time and position here. I am using just approximately that x1, x2, x3, x4 and x5 are located on this curve here. If we draw the curve for the particle, say it changes its position somewhat in this way. What here we obtain starting of the motion, and it is the end of our observation. What you see here, that at different time particles velocity is different because of the curved shape, because of the curvatures of the curve between position and time. This curvature represents the way by which position is changing. As we know, curvatures of this curve are different between different time intervals. So in a particular time interval, if I draw tangents at each point, then those tangents may have different angles with the time axis, means different velocities. See, how can we see that by what way velocity of the particle is changing? So for this conclusion, we will do something like that. We can easily say that velocity at this time t4, it is 0. That's why the tangent has here slope to be 0. That's why the velocity of the particle is 0. If we talk about a point an instant before, say this point, at this point of the curve, no doubt velocity is something positive because angle made by this tangent with the positive time axis is positive. So positive velocity this point indicates because the slope to the tangent is positive here. While for a time a little longer than t4, we can say that at this time slope to the tangent drawn at this point have the negative slope because it forms negative angle with the positive time axis. So here particle has negative velocity. What will we do from this information here? You can say at this place, at the topmost point of this curve corresponding to position x4, which was at time t4, you can see that initially the velocity was positive. It decreases to 0 and then finally becomes negative. So rate of change of velocity at this place can be considered as negative. Why it is negative? Because initially velocity was positive, then finally it becomes negative. So the change in velocity is negative. That's why rate of change of velocity, which will be further defined as the acceleration, is negative. Let us consider a situation. I am asking to you small, very simple question about the acceleration, because in some cases in the various competitive examinations like IIT, AIEEE, questions have been asked on this fact. Displacement time curve was given and asked about the instantaneous velocity and instantaneous acceleration of the particle. No doubt, by taking two nearby tangents at that point, if slope is decreasing, then obviously acceleration will be in opposite direction, while in case of if tangent is increasing its slope, then for increasing slope we can say that acceleration is positive. Positive means in the positive direction of motion its velocity is increasing, and what is the negative means that velocity is decreasing because angle changes from a large value to smaller value or from positive to negative. Just see, if I am asking you that at this place what is your observation, here I have just given you curve. Initially this curve was this and finally it goes flattered. What is the mean of this flattered curve a little time after the time corresponding to which we have taken this point? You can easily do it. Just draw a tangent here. Tangent has the positive slope, so velocity is positive. If we take another point just nearby it and again draw a tangent, then you can say that slope of the tangent decreases as we move further from time t to t plus delta t. So here velocity is decreasing. Velocity is decreasing means the acceleration is negative. So here we observe a negative acceleration. If we talk about 2 points, one point is here and other point is here. For two corresponding time t and t plus delta t here also, we can say that if we draw the tangent at the first point, we get slope in this way, while for the other point on this curve, slope increases a little bit. It gives the idea, the fair idea about the increasing velocity. As you know, increasing velocity gives an idea of some positive acceleration. So here at this point you can say that acceleration is positive. Get an idea? If we go further at the entire curve, what we can observe is that here slope is decreasing, so acceleration is negative. Here slope is increasing, so acceleration is positive. In this section it is negative again. In this section it is positive, and here at the topmost point, near the topmost point, acceleration is negative. It is negative, 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 negative. Have got my point? What is the acceleration here? If we assume the direction of motion to be positive, then after this point acceleration as it becomes negative and particle is also moving in the negative direction. So for that convention, when we are taking motion of the particle to be positive, in this segment acceleration is positive. So what you have observed from here, just write down in the definition form that instantaneous velocity which was given. What you achieve from this point is the main part of this curve is about the acceleration, and this acceleration is defined as the first derivative of velocity with time. It can also be written as second derivative of the position, which finally may be positive, may be negative, or may be zero. Because if we talk about a displacement time curve which is a straight line, then at the place where displacement time curve or the position time curve is a straight line, you can say for that particular time interval acceleration of the particle is 0. So from the curve we can get the acceleration by slope of tangent to velocity time curve, because it has been defined as the first derivative of velocity with time. So this means that acceleration can be achieved by taking the slope of tangent on the velocity time curve. Now we have studied displacement time curve for the three things: average velocity, average speed, instantaneous velocity, instantaneous speed, and finally average and instantaneous acceleration. So from this also it is clear that particles motion from this curve we can study by what means, in what way particles position is changing and particles velocity is changing. There are many questions asked in various pre-entrance tests. Many questions have been asked in previous years in various engineering and medical competitive examinations. I am just considering few questions